All right. So if you are in my pre-calc class, this is for you. All right. If not, and you're just here looking for this content, hopefully you get something out of it. All right. But we're looking at applications of composite functions. All right. So this is really neat. I love these kind of word problems because, of course, students love to ask, when am I going to use this in the real world? So showing them applications shows them that. All right, perfect. So let's get started. Okay, the number of N bacteria in a refrigerated food is given by this quadratic formula here. Okay, N of T, right? Where T is measured in temperature, okay, in Celsius, the temperature of the food in Celsius, when the food is removed from the refrigerator, okay, it's given by, and then we have T of T, it's given by this linear function here. All right, so I do want to state here, let's make it, um, lowercase t is time in hours. Uppercase T is temperature of the food after so many time in hours, right? So let's make that distinction here that T, uppercase T and lowercase t are not the same thing. Okay, so find and interpret the composite function. Okay, what is the number of bacteria after 5 hours, and how long will it take for the bacteria to reach this certain number here, 2,221? All right. So you can see here, there's no direct jump between number of hours and the number of bacteria. Okay, we have to go through temperature first. We have to, if we're at time, we have to go through temperature to get to the number of bacteria. That's why you have to use a composite function. Okay, there's no direct jump between time and hours to the number of bacteria. So to find the composite function, remember we're going to take this n of t here, n of t, right? And we're going to replace every capital T with the quantity of 2t plus 5. So I'm going to rewrite n of t. Let's go with black. Why not? Good old fashioned black. N of t equals 5 times the quantity of 2t plus 5 squared, right, minus 4t, where t is now 2t plus 5. I'm going to put a little hook on my t's so they don't look like plus signs. 2t plus 5 plus 100 plus 100. Nice. Okay, so we can certainly clean this up, right? On the right-hand side, it's just following PEMDAS, really. Make sure you FOIL these two binomials here before you put that 5 in. Otherwise, you're squaring the 5, right? We don't want to do that. That's not what is happening, right? So let's go ahead and do that. N of t equals 5. And then I'm going to rewrite this. I just want it to be extra obvious what's going on here. The quantity of 2t plus 5 times the quantity of 2t plus 5. All right. And that comes from this exponent of 2 here, right? Minus 4 times the quantity of 2t plus 5. Plus 100. Perfect. All right. Now, let's go ahead and boil these two, right? Remember, first times first, outer times outer, inner times inner, and last times last. Right, let's go ahead and do that. So we have 5 times first, 2t times 2t, 4t squared, right? 2t times 5 plus 10t, right? That was the first, and that was the outer. Now the inner, 5 times 2t gives us another 10t, right? And then 5 times 5 plus 25, right? And we can distribute this 4 here, this negative 4 to the 2t. We got minus 8t, and then negative 4 times 5, negative 20. And I still have my plus 100. Don't forget about him. All right, cool. Now we're just going to put this 5 here, right? Distribute this into this quantity. So I have 5 times 4t squared, 20t squared. I can put these two like terms together, right? They're both t's. I have 10 plus 10. That's 20. And let's go ahead and distribute that 5 to the 20 plus 100t. And now I have my plus 25 here. Once I distribute the 5 there, no different than having 5 quarters, right? Okay, minus 8t. And then I have a negative 20 and a positive 100. So let's go ahead and put those together. Let me give me some more workspace here. All right, cool. We got some more like terms we can put together, and we should. So n of t. All right, for the t squareds, I only have the one term, plus 20t squared. For the t's to the first power, I have 100, and then I have a negative 8. We can go ahead and put those together. And for my constants, I have 125 and I have 80. Let's go ahead and put those together. Perfect. Okay, so the first question was asking us to find n of t, and we did just that right here. So let's go ahead and put that in. Noise. N of t equals 20t squared plus 92t plus 205. Yay. What is the number of bacteria after 5 hours? Okay, so they're asking for number of, which is what this right hand, sorry, I misspoke, this left hand side is going to represent, is the number of. Okay, after 5 hours, so we know lowercase t measures time, so let's go ahead and replace lowercase t with 5. So, whoopsies, n of t of 5. All right, equals, so for every lowercase t, I'm replacing it with a 5. All right, plus 205. Okay, so now you would just follow PEMDAS here to simplify the right-hand side. I did go ahead and do this in the calculator for us, which I would certainly hope you would do that on the test. Well, I don't know why you wouldn't. But once you do here, you'll see that after 5 hours, we have 1,165 bacteria. Super cool, right? It's pretty awesome. Let's go ahead and put that there. Nice job. Yeah, okay. So the next one is, how long will it take for the bacteria to reach 2,221? So they're saying, how long will this take? So we know our variable is going to be time, because in a word problem, whatever they're asking for is usually the unknown, right? That's why they're asking. So we'll be solving for lowercase t. Perfect. So we're going to take our composite function that we found, and we're going to set that equal to 2,221 equals 20t squared plus 92t plus 205. And then solve for t, right? You can see here you do have a quadratic. So remember your options. right? You can factor if it factors, right? Maybe it does, maybe it doesn't. Completing a square quadratic formula would always work, right? I would go with quadratic formula here. Okay, um, that's what I would do personally. But to do that, before we can just start plugging away into the formula, that has to be in standard form, right? So we can identify what's A, what's B, and what's C. So I'm going to go ahead and subtract 2,221 from both sides. That's going to set it equal to 0 and put this in um, standard form, right? Let's do that. So I'm subtracting this from both sides. So 20t squared plus 92t, no, 205 minus 2,221, negative 2016. Yes, now it's equal to 0. Perfect. Okay, so quadratic formula. Let's go with that. Why not? Okay. Remember, A is going to be the leading coefficient, whatever's in front of t squared there. Normally it's x, but I mean xt, whatever. It's all the independent variable there. All right, there's only lowercase t here because we're talking about time. It could have easily been x. Don't let that throw you off. A equals 20, right? And then whatever's in front of t is your b. In this case, it's 92. And then c here is our constant of c equals negative. Please bring this negative with you. Okay, please do that. Negative 2,116. All right, cool. So we're just simply going to plug this in. Right, t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, nice. All right, so plugging them in, right, we get t equals negative 92 plus or minus the square root of 92 squared minus 4 times 20 times negative 2,116, right? That's all being divided by 2a. 2 times 20. All right, perfect. So I would certainly put this into the calculator, right? Especially your discriminant here. All right. And I actually did already for the sake of time. Let's put it in Desmos, right? And you can see because we do have the plus and the minus, right? I just simply plug it in the Desmos and make this a little bigger. Right, these are values for t, or values for time. Right, how long will it take for this bacteria to reach the 2,221? All right, we'll put it in once with the plus sign and get 8 hours. Put it in again with the minus sign and get negative 12.6 hours. Right, which if you think about it, your answer should make sense, right? Does negative, because this represents time, does negative time make any sense? Right, I don't know how that would work if it exists in another dimension. I don't know, but my point here is we're going to ignore this t equals negative time, right? And we're going to go with 8 hours. Okay. Yep. Oh, let's just put it up here. T equals 8 hours. Yeah, and that's really it. Okay. Hopefully this helps. Yeah. Yay.